Hello students, I am Dr. Ragini Aroda and welcome to Aditya Academy. And in this video, we are going to finish exercise 8.3 from NCERT. In the previous video of this exercise, we had done 3 questions. And since this question 4 has got 10 parts, so I am making a separate video for this. So let us start solving these questions. In this, we have to prove the following identities where the angles involved are acute angles for which the expressions are defined. So let me write the basic first 3 identities here. They are sine squared theta plus cos squared theta is equal to 1. Second one is 1 plus tan squared theta is equal to secant squared theta. And 1 plus cot squared theta is cosec squared theta. So we can use these 3 basic identities as the standard results and we can come to these identities, right? What you have to do is you have to prove the LHS being equal to RHS. So you need to learn the presentation. When this identity is given to you, you either need to start it from the LHS or from the RHS. You need not copy down both the expressions LHS and RHS at the same time. So here I am starting with LHS, and the very basic thing is to copy down that left hand side first. LHS expression is cosec theta minus cot theta whole square. Now, what we can say, whenever you start proving the identities, you always need to check what terms you are getting on the right hand side. If you are starting from left hand side, check for the terms you want in right hand side. So then you need to analyze whether you have to use either of these identities or the relationship between the reciprocals of trigonometric ratios or any other relationship. So here the basic thing is we need cos theta on the right hand side. So first of all I am opening this cosec theta in terms of 1 upon sin theta. See, you have to analyze. This bracket can be opened like this is a square plus b square minus 2ab. But still you will be getting those terms as cosec square theta, cot square theta into minus 2 cosec theta, cot theta. So that will become difficult to open at the later stage. Though you will be able to get it even if you open it like this. But you should be able to analyze what is the easiest route to get to the right hand side. So I am opening this in the terms of sine and cos inside the bracket. The cot theta can be written as cos theta by sine theta, keeping this square outside. Next we can write this as denominator becomes sine theta for both the terms as sine theta, and then in numerator we can write this as 1 minus cos theta whole square. Now see, try to relate this thing with the RHS. You have already got this term in the numerator, right? So this is very easy. Had you been open this as a square plus b square plus 2ab, it would have been very long question. So now what we can do, we can do it separately, like we can break this square for numerator and denominator. Now we already have the term, but only thing is it is in the square. What we can do in the denominator so that we get sine square theta in terms of cos square theta. See here. From here we can see that we have sine square theta, so we can write sine square theta as 1 minus cos square theta, right? So I'm writing it here. Next we can do is we can write this as 1 minus cos theta into 1 minus cos theta. Whole square can be written as product of 2 brackets. In the denominator, we have 1 minus cos square theta, which can be related to a square minus b square. So we can open this as 1 plus cos theta, 1 minus cos theta, right? 1 plus cos theta and 1 minus cos theta. So what we can do here is we can reduce these 2 brackets. So now we have got what we wanted in the right hand side of this equation. Right, this is equal to RHS. Hence we have proved this first identity, right? Next question is, okay, so in this type of question, we always should start with taking the LCM of the two denominators. Here I'm starting with the left hand side. Just copy it down. Don't start solving it by using this as the base. First you have to note it down, then start solving it. 1 plus sine A plus 1 plus sine A upon cos A. So now your LCM becomes cos of A in bracket 1 plus sine A. Now divide this denominator by this denominator. See, children generally find it difficult. How do we do this? When we have this whole expression in the denominator, divide this denominator by the denominator of this expression. So this 1 plus sine A bracket gets reduced. We are left with cos A. This cos A gets multiplied by the numerator. So we have cos square A. Right? Take this whole LCM. The product of both the denominators I have taken as LCM. Now this whole denominator gets divided by the denominator of first expression. So cos A into 1 plus sine A divided by 1 plus sine A. This bracket gets reduced. So we have cos A. Cos A multiplied by cos A is cos square A. Now divide this denominator by this denominator. So cos A get reduced. 1 plus sine A gets multiplied by 1 plus sine A. So we have 1 plus sine A whole square. I hope this is clear now. So now what we can do is we can open the bracket. Here we have A plus B whole square, so which is A square plus B square plus 2AB. 2 into 1 into sine A is 2 sine A. And denominator, you never try to open this by opening this bracket and making it an expression, because when we have these in the factors form, we can reduce it at the end of the expression. If you open this, you will not be able to do that. So we have cos A multiplied by 1 plus sine A. Here we have cos square A plus sine square A, which is 1. 1 more 1. 1 added to 1 plus 2 sine A. So now we have cos A into 1 plus sine A in the denominator. So we have 2 plus 2 sine A divided by cos A 1 plus sine A. I'm reminding again, you should never open the denominator into an expression form, like a polynomial form, because if you have the terms in product, you can reduce it in the later stages of the calculations. Now here I take 2 common. In bracket I have 1 plus sine A. In denominator we have cos A 1 plus sine A. Now you can see it here. This bracket is common. So we have reduced this and we get 2 upon cos A, which is 2 secant A, and this is RHS. Right? Next one is, this is very important question. So in the NCERT, a hint is given that you should express tan theta and cot theta in terms of sine and cos. I would like to give you a different approach, which is quite easier if you feel that. Let's see. LHS is tan theta divided by 1 minus cot theta. Here we have cot theta 1 minus tan theta. I am, instead of replacing cot theta and sine theta, cot theta and tan theta in terms of sine and cos, I am simply replacing cot theta by 1 plus tan theta. Tan theta remains same, and in the denominator I am writing this as 1 upon tan theta here, right? And in this one I am writing here as 1 upon tan theta in the numerator, and in denominator we have 1 minus tan theta only. I have simply replaced cot theta by 1 upon tan theta, nothing else. Now I am simplifying this expression. This is tan theta in the numerator. In denominator, you keep tan theta as denominator, multiplied by 1 is tan theta minus 1. Plus, here what we can do, see, it is 1 upon tan theta. Let me tell you one thing. Children generally get confused about this expression. Where shall this tan theta go? Should it come into the denominator, or should we take 1 minus tan theta in the numerator? Let me solve this problem. If we have x upon y divided by z, what you can simply do is treat this bigger line as the main division sign. So we can write this as x upon y. This is your numerator right now. This whole thing is divided by z, right? So you can write this as x upon y multiplied by 1 upon z. This is how we do it. We convert division into multiplication and take the reciprocal of the second term. So what happens? X upon y z. That means this should come out here in the multiplication. Try to do this in few questions by doing it this way, in the elaborated way. At least you will get the correct answer. Don't try to mug it up. Like we have to take this in denominator, this has to be taken into numerator. Try this way. This is very simple. The bigger line has to be treated as the division sign, and then everything will fall into place when you do it in the basic method. So now this is 1 upon tan theta. I am taking it here, multiplied by 1 minus tan theta. And simply here we have this expression, like we have only one thing in the numerator, divided by y by z. Now how do we do this? X divided by y by z. So what do we get? X multiplied by z into. This is x z upon y. That means this x and z, this tan theta goes into the numerator. So this becomes tan square theta. Tan theta minus 1. And here we have 1 upon tan theta in bracket 1 minus tan theta. I hope this complexity is resolved now by taking these simple steps. Now what else can we do? Now check for the denominators. We have this bracket common apart from the opposite signs. Here we have tan theta minus 1. Here we have 1 minus tan theta. So if you have a good hand at factorization, I keep this bracket same, the first one, and I take out minus sign outside, and this becomes tan theta, and in bracket instead of 1 minus tan theta I can write tan theta minus 1. I have taken minus sign common outside. This expression on whole becomes negative. Why I have done this? So just to make these two brackets same, exactly same, right? So now we can simplify it further by taking the LCM. The LCM becomes this tan theta, and in bracket tan theta minus 1, since it is common to both the denominators, I have taken it once. Divide this denominator by this denominator. Tan theta minus 1 gets reduced. This is common. We are left with tan theta. This tan theta gets multiplied by tan theta. It becomes tan cube theta. And this whole denominator is same as this one. So when we divide this by this, we get 1. 1 multiplied by 1 is 1. We can write this as a cube minus b cube. Now I am using this identity. A cube minus b cube is a minus b, in bracket we have a square plus ab plus b square. So tan theta minus 1, a square is tan square theta, plus 1 into tan theta is tan theta, plus 1 square is 1. So we have tan theta in bracket tan theta minus 1. This bracket is reduced now. Now we can take this tan theta below all the terms in the numerator. So tan square theta divided by tan theta is tan theta. Tan theta divided by tan theta is 1. 1 divided by tan theta is cot theta. This is the simplified version, right? But see, this is not what we had to find. We have to reach here. 1 plus secant theta cosecant theta. So 1 is something which is required, so I am not disturbing it. Now tan theta plus cot theta has to be simplified further. So what I am doing is, I am writing them in terms of sin theta and cos theta. Tan is sin upon cos. Cot is cos upon sin. Right? So we have 1 plus, in bracket, take this LCM, sin theta cos theta. Cos theta gets reduced, sin theta gets multiplied by sin theta, which is sin square theta. Sin theta cos theta divided by sin theta is equal to cos theta. Cos theta multiplied by cos theta is cos square theta. So we have 1 by sin theta cos theta. Sin square theta plus cos square theta becomes 1. So finally we have got 1 upon sin theta is cosec theta. 1 upon cos theta is sec theta. And this is our RHS. Right? So both the questions are equally lengthy. It is up to you what you have to follow. Whether you like this method or converting this into sin theta cos theta, it is up to you. But this question is very important. Practice this 2 or 3 times at least. A divided by secant A is equal to sin square A upon 1 minus cos A. I am copying down the LHS part, 1 upon secant, 1 plus secant A upon secant A. Now we require the terms sin A and cos A in RHS. So first of all, I am converting secant into cos. This is 1 plus 1 upon cos A divided by 1 upon cos A. So we have, like here I can take LCM, cos A. This cos A gets multiplied by 1, so it becomes cos A plus 1. And in denominator we have cos A. Here when we have 4 numbers, like 1 fraction in the numerator, 1 fraction in the denominator, let me tell you how do we solve this. If we have A by B upon C by D, this means A upon B, treat this as division, divided by C by D. So how do we get this? We get this as, convert this division into multiplication. This becomes D by C. So what do we get? AD upon BC. That means you have to flip the lower fraction. So we have 1 plus cos A divided by cos A multiplied by cos A upon 1. So now we get 1 plus cos A, right? But see, this is not something that, this is a simplified version of LHS till now, but this is not something that we require in the RHS. So what do we require? We need 1 minus cos A in denominator. So if there is nothing in the denominator, we can introduce that 1 minus cos A, and to balance it, I am multiplying this by 1 minus cos A. You have to learn this. Whatever is required, you have to modify your expression to reach to that point. This is 1 plus cos A, 1 minus cos A plus B, A minus B is A square minus B square. And in the denominator we have 1 minus cos A. 1 minus cos A we have got. And numerator gets modified itself. 1 minus cos square A is sin square A upon 1 minus cos A. So this is your RHS. Right? This is one of the best questions. See, in this we have to open 1 in terms of difference of 2 squares, right? But the thing is, when we take the identities like secant square theta minus tan square theta can be written as 1. So if this was a relationship between tan and sec, we would have started directly. Otherwise, we can write cosec square theta minus cot square theta as 1. So in such kind of questions, when we have tan sec and 1 or cosec cot and 1, if there were tan and sec or cosec and cot, we would have started directly. But see, we cannot write cos square theta minus sine square theta as 1 because this is equal to sum of these two ratios, the sum of these two trigonometric ratios, squares of ratios. So first of all, we have to reach to a point where we can use this 1 as the difference of two squares. Right now we cannot open this 1 as cos square theta minus sine square theta or vice versa. For that, I need to convert this identity into either secant with tan or cosec with cot. Now that is decided by the values in the right hand side. What you have to check? What is the common denominator for both the terms in the RHS? This can be written as 1 upon sine A, and cot A can be written as cos A upon sine A. So in both the expressions, you have, in any kind of question, you have to open the right hand side first. And when we have cos and sine in the expression, if you are getting sine A in the denominator, you have to start with dividing numerator and denominator by sine A. Right? I will be explaining you this. In that case, you will not be able to just keep on writing and memorize this question without any logic. LHS is cos A. First of all, I am copying this LHS, sine A, cos A plus sine A minus 1. So let me summarize this again. If this type of question, when we have 1 with two other trigonometric ratios, if it is in the terms of secant and tan, you can start it directly. Or if it is in the form of cosec with cot, you can start it directly. But if it is in the form of cos and sine with 1, first of all, you have to divide both the numerator and denominator either by cos A or by sine A, depending on the denominators of the RHS. The denominator of RHS is sine A in both the terms. So I write divide numerator and denominator by sine A. Right? So I'm writing it in elaborated form. Cos A upon sine A minus sine A upon sine A plus 1 upon sine A. Here is the main division line. In denominator we have cos A upon sine A plus sine A upon sine A minus 1 upon sine A. Right? Now write, what do we get? Cos A upon sine A becomes cot A. This is 1. 1 upon sine A is cosec A. In denominator we have cos A upon sine A is cot A. Then sine A upon sine A is 1. Then we have minus cosec A. See, I had told you if you have cosec A and cot A in both the expressions, you can solve it further. If you have secant and tan, then the next steps are required, but these two steps are additional in this kind of question when we have sine A and cos A along with 1. So now solving it further, what I am doing is I am writing this as cosec A plus cot A in a bracket minus 1. Denominator you can write this as cot A plus 1 minus cosec A. Only in the numerator you have to open 1. You have to open 1 and write this 1 as the difference of two squares, like in cosec square A minus cot square A. Cosec square A minus cot square A. Do not open or do not do anything in the denominator. Cot A plus 1 minus cosec A. Leave it. This will get reduced finally. So now in the numerator we have cosec A plus cot A in the bracket. Keep it in a bracket. Here you can write this as A square minus B square is A plus B, A minus B. Cosec A plus cot A, and then cosec A minus cot A. Right? Denominator remains same. Cot A plus 1 minus cosec A. Now what we do in the numerator is take this as the whole expression. You can see that cosec A plus cot A bracket is common to both the terms. We have minus here. This bracket is present to the left of minus sign, to the right of minus sign. So I am taking cosec A plus cot A common. Now in the bigger bracket, since everything has been taken out from the first term, we are left with 1 minus, in the second term, this has been taken out, we are left with this bracket, cosec A minus cot A. Denominator remains same. Cot A plus 1 minus cosec A. So now when we write this as cosec A plus cot A, right, open this bracket, 1 minus cosec A. When this is bracket is preceded by minus sign, both the signs get reversed. This becomes plus cot A divided by cot A plus 1 minus cosec A. So you can check here. This is cot A plus 1. These two terms are positive, cosec A is negative. 1 plus cot A is positive, cosec A is negative. So these two brackets get reduced. Finally we have cosec A plus cot A, which is nothing but RHS. Right? See, we have got modifications of this question in several books. In some cases, we have to divide numerator and denominator by cos A. So I'm telling you the reason. You first go by RHS. Check the common denominator for all the terms in RHS. When we have sine and cos along with 1, you have to first check for the RHS. If it has got both the terms with cos A as common denominator, divide numerator and denominator by cos. Here we had sine, so I divided numerator and denominator by sine. And if, apart from these two cases, if we have questions in the form of tan, sec and 1, we can directly start from here. Cosec and cot, we can directly start from here. These 2-3 steps are not required in that case. So I hope this is clear. You can have different variations of this question. So you should have got one reason, that 1 has to be opened in the numerator and 1 can be written as the difference of two squares. Then you will follow the steps. Next is LHS is square root of. These type of questions have a common need. Whenever they are under the root and this binomial expressions, we always take the conjugates of these terms to simplify them. So I am multiplying the numerator and denominator by conjugate of 1 minus sine A, which is 1 plus sine A inside the root. Right? So here, instead of opening it randomly, see, you need to come out of the square root because we don't have square root in the RHS. What we have to do is we have to find squares. So instead of opening it as A plus B whole square, write it in the form of a square. 1 plus sine A whole square. In denominator we have 1 minus sine A, 1 plus sine A, which is A square minus B square is 1 minus sine square. Because they think this is 1 square, this is 1 square, and simply they write it 1 plus sine A and 1 minus sine A, which is not good. Right? So what you shall do is you should take the square. This is not, because see, square root of A square plus B square cannot be written as A plus B. Only A plus B whole square can be written as A plus B. So please follow these rules. Now, in the numerator, we keep this bracket as the whole square itself. 1 plus sine a whole square. In denominator, 1 minus sine square a by the identity can be written as cos square a. Now we can take the square root of numerator as well as denominator. So we get 1 plus sine a in the numerator, and in denominator we get cos a. So we take this denominator below both the terms. 1 upon cos a plus sine a upon cos a. So we have secant a plus tangent a, which is RHS, right? Next is, this is sine theta minus 2 sine cube theta. This is 2 cos cube theta minus cos theta. Now how can we start with this? We require tan theta in the right hand side of this equation. So in the numerator we can see that sine theta is common to both the terms. I am taking it out. When we take out sine theta, we are left with 1 minus 2 sine. 1 sine is reduced, it is 2 sine square theta. In denominator we have cos theta common to both the terms. We are left with 2. Out of 3 we have taken 1, so we are 2 cos square theta minus 1. Now this is very good way. If you see in the RHS you require only tan theta. And if we check about this, sine theta upon cos theta itself is tan theta. That means we have to ultimately get this thing only to prove this identity. That means this and this bracket, these two brackets mean the same thing. That means when we reduce them, we get 1. So you have to approach it that way. What is required and how can we get there? So if we keep sine theta and cos theta same, we have to look for something we can convert these two into the same expressions. Now what we can do? We have a relationship between sine square theta and cos square theta. Sine square theta plus cos square theta is equal to 1. But see, if I use this sine square theta and convert it into cos square theta and do the same in the denominator, I convert cos square into sine square, then again we will get stuck. So keeping 1 as same, we can do it with either of the things. Like I can change the numerator keeping denominator same, or do the vice versa. So I'm keeping numerator same. Instead, I am using this relationship in the denominator. Cos square theta can be written as 1 minus sine square theta. I did not change this sine square into cos square, because if I would have done that, in the numerator I would have got cos square, in the denominator I would have sine square. Then again I would have got stuck. Instead, I am only converting one expression to reach to the common point. Now this is 1 minus 2 sine square theta. In denominator we have 2 minus 2, 2 minus 2 sine square theta minus 1, which can be written as sine theta by cos theta 1 minus 2 sine square theta. In denominator, this is 2 minus 1, which is 1, minus 2 sine square theta. Now you can see these two brackets have become same. Now we can reduce them, and finally we get tan theta, which is RHS, right? This is a very interesting question. LHS is sine A plus cosec A whole square plus cos A plus secant A whole square. Now see, what is required in the right hand side of this expression? We require tan square and cot square. right? And a big number, which is 7. Now, how can we get 7 from this expression, right? So what you have to do is go by opening, instead of treating this as 1 upon sine A, 1 upon cos A, it will become lengthier in this question. So instead, since this big number is required, you start opening it by using identity like sine A plus cos A. So I am applying A plus B whole square, which is A square plus B square plus 2AB. 2 into sine A cosec A. See, by just looking at these two things, if we get 2 sine A cos A, sine and cosec are reciprocals of each other. So they, in multiplication, they get reduced to 1. So this term becomes only 2, right? At this time, you should be able to do these questions already, like cos square A, this is A square plus B square is secant square A plus 2AB. 2 cos A sec A. So now what we can do? Club these two terms. Sine square A plus cos square A. Then we have cosec square A. See, we have cosec square A, but cosec square A is not required in the right hand side. We also have secant square A. Then we have 2 sine A, and cosec A can be written as 1 upon sine A. 2 cos A, secant A can be written as 1 upon cos A. Right? Now we have segregated these expressions. This cos A gets reduced, sine A gets reduced. This sine square A plus cos square A is 1. Cosec square A can be written as 1 plus cot square A. Secant square A can be written as 1 plus tan square A. And these sine A got reduced. We have 2 multiplied by 1, 2, 2 multiplied by 1, 2. So finally we add up all the numbers. 2 plus 2, 4, 5, 6, 7. So we have 7 plus cot square A plus tan square A. And this is what we had required in the address, right? Now the next question is, this is cosec A minus sine A multiplied by secant A minus cos A. So now if we say that if we multiply by opening these terms by of one bracket by other bracket, we will not get something considerable. Cosec A into sec A cannot be expressed somewhere. So I am simply writing this as cosec A can be written as reciprocal of sine A. 1 minus sine A. This is reciprocal of cos A minus cos A. Now we simplify it further. This is sine A, and we get 1 minus sine square A. Then we have cos A. 1 minus cos A into cos A is cos square A. 1 minus sine square A is cos square A. And in denominator we have sine A. 1 minus cos square A is sine square A divided by cos A. Now see, what we can do is we can reduce this sine A and sine A, 1 cos A and cos A. So we get cos A into sine A. This is a simplified version of left hand side of this identity or equation. Now we can see that if we have to find this, we have to reach to this point. This cannot be done by using this term. So instead we can solve RHS of this identity and bring it to the same point if it is possible. See, 1 upon tan A plus cot A. Now what I am doing here is I am converting tan and cot into sine and cos terms. This becomes sine A upon cos A plus cos A upon sine A. Right? So further what we can do is 1 upon, take the LCM in the denominator, which is cos A sine A. Divide this cos A sine A by cos A. We get sine A multiplied by sine A is sine square A. Cos A sine A divided by sine A is cos A multiplied by cos A is cos square A. This is in the form of A divided by B by C. So we can write this as A divided by B by C. So A multiplied by C by B. AC by B. That means this C goes into the numerator. Cos A sine A upon sine square A plus cos square A. Right? And this is 1. So we have this as cos A sine A. So we can see that in this case it was not very comfortable to start from here and reach up to this point. So instead we solved RHS to the common point, and we can see that at some point both these left hand side and right hand side are coming to the same level, that is cos A sine A. Right? Now the last question is, we have left hand side. This is equal to, note it down, this is 1 plus tan square A upon 1 plus cot square A. This has got two different parts. So we start with the left hand side and see. 1 plus tan square A by the identity can be written as secant square A. 1 plus cot square A can be written as cosec square A. Now if we want to have simplified version first, we can write secant square A as 1 upon cos square A, and cosec, keeping 1 here, we take sine square in the numerator. So this is equal to sine square A upon cos square A, which is tan square A. So we can see that first part in this direction we have already proved. Right? Now what we can do is we can either prove it this equal to this so that all the three parts become equal. So how can we do that? Now I am starting with 1 minus tan A upon 1 minus cot A whole square. Now I am solving this inside this bracket in terms of sin A and cos A. This is 1 minus sin A upon cos A divided by 1 minus cos A upon sin A, and this raised to the power 2. So what we can see here, taking this as the denominator cos A, this is cos A minus sin A. This whole thing is raised to the power 2. We are solving just inside the bracket, and this becomes sin A minus, sorry, I had to write this in the numerator. We can write this as sin A minus cos A upon sin A. Now how can we do this? If we have 4 ratios, A by B, C by D, we need to keep this in mind, A into D and this B into C. So what we can do here is cos A minus sin A upon cos A. Right? And we flip the denominator so that this becomes sin A, and this is sin A minus cos A, and this is under the whole square. Now see how can we do this. This is cos A minus sin A, this is sin A minus cos A. When we have exactly same expression with the opposite signs, we can take out minus sign common from either of the two brackets to make them same. I am taking out minus common from the numerator. So this becomes sin A minus cos A multiplied by sin A, and in the denominator we have sin A minus cos A into cos A. So now after taking out this minus sign common, we can reduce these two brackets. So we have minus of sin A upon cos A whole square. And when we take the square of a negative term, it itself becomes positive. So we have tan square A. Right? Now you can see that we have proved the first part equal to tan square A and the second one also tan square A. So we can say that ultimately they all three are equal. Right? So this was all about the chapter of trigonometry. I hope these 10 parts are bit that you need revision. Otherwise this chapter is very interesting and easy. I hope you found my video very helpful. I would request you to like, subscribe and share it with your friends. Thank you.